Hello, can you hear me? Yes, hello. Can you see my screen? Is it visible, my screen? Anyone? Hello? Can someone respond? Is it visible or am I audible or not? Hello? Yes? Okay. Okay, then let's start. So now can you see the assignment? Okay. So today is week 3 of the course MA 49. Today we will discuss the assignment 3 of the previous run course. So let's go to the first question. What it is saying, if f and g are any two real valued differentiable function and h is what it is defined, f compose g, then what you have to find the derivative of h, what it will be. So you have to say it is true or false. So f and g are real valued differentiable function and h is defined f compose g, means h of x is f of g, f of g of x, right? This is f compose g of x, and you know the chain rule, right? It was done in the class that if some h is a composition of two functions, then we can differentiate h in terms of using the chain rule. So what will be the derivative of h? Then by chain rule, h dash at x, it will be f dash at the point g of x, and now you have to derivative g at the point x, right? So by chain rule, h dash x will be f dash of gx into g dash of x, but what it is given, so this is true for all x belongs to R, but it is saying that h dash of x is g dash fx at fx into f dash x. So it is wrong, right? So the answer will be false. Is this fine? This is by chain rule, first one, right? Okay. So then move to the next question. Okay, here what it is saying, consider the function fx equals to square root of x minus 1 into 2 minus x, right? So in domain is x belongs to 0 to, right? Can someone say, is this function well defined or not in this domain? If fx is given by square root of x minus 1 into 2 minus x, or x belongs to 0 to, is this function well defined? Because first the function should be defined in the where it is defined, then we can talk about the Rolle's theorem applicable or not. Is this function well defined in x belongs to 0, 2? So what happens when x will be 0? So if we put f at the point 0, then what happens? It will be minus 1 times 2, right? But square root is only defined for positive numbers, right? So this is not well defined, right? So fx is not well defined for all x in 0, 2. So you cannot talk about, because f0 is not well defined. So you cannot talk about the Rolle's theorem, because for Rolle's theorem, if you want to apply the Rolle's theorem in interval f of yes. So if you want to apply the Rolle's theorem in the interval a comma b, then fa and fa should be well defined, right? Fa and fb should be well defined, and in between it should also be. But here the function is not well defined for x less than 1, right? But f is not defined for x less than 1 greater than 0, right? Equals to 0. So we cannot talk about the Rolle's theorem. So this will be the false, means we cannot simply talk about the Rolle's theorem. So this will be false. But we can, if we just modify this function, so let modify this function. So fx, so it's only problem in for x less than 0. So you can modify it, x minus 1 into 2 minus x. So if we take for all x belongs to 1, 2, then there is no problem, right? Then fx is well defined. Then f is well defined, right? And what will be then you have to, this is because x minus 1 and 2 minus x both are continuous function, square root is also continuous function, so composition is continuous function. So clearly f is continuous on 1, 2 and also differentiable, because square root is differentiable in 1, 2 and also differentiable in open 1, 2, right? Because we only need in the open interval, we do not need at the end points for Rolle's theorem. And now what will be the f of 1? So f of 1, if we put 1 here, the function will be 0, and f of 2, it's again it will be 0, right? If we put, so fa equals to fb, both are 0, and f is continuous in the closed interval ab and differentiable in the open interval ab. So now you can apply the Rolle's theorem. So then we can apply Rolle's theorem. We can apply Rolle's theorem, right? So if we define it from 1, 2 f function, then we can apply Rolle's theorem. But here the function is defined in the interval 0, 2, right? So there is a problem for x less than 0. So the answer will be false. You cannot apply the Rolle's theorem, means hypothesis will not be satisfied. F of 1 is not well defined, right? And also we cannot talk about the continuity and differentiability in between 0 and 1. So 2 is false. Okay, so this is done. Any question with this? Okay, if not, then move to the next question. So now move to what is the question number 3? ft is given by, f is a function ft which is given by e to the power 7th root of the square. So this you can write e to the power t to the power 2 by 7, right? So then you have to find the f dash at 1, at the point 1. What will be the value? F dash at the point 1. So first, because this function is differentiable, right? Square root, exponential, all are differentiable for positive. For square root function is all defined for positive, and there it is also differentiable. So everything is differentiable. So just differentiate it, then f dash t, what it will be, e to the power t to the power 2/7 into, now you have to differentiate the function t to the power 2/7, so what it will be 2/7 into 2 to the power 2/7 minus 1, right? 2/7 minus 1, then what it will be, e to the power t to the power 2/7 into 2/7 t to the power minus 5/7. So this is the derivative, means we can write it 2/7 t to the power minus 5/7 into e to the power t to the power 2/7. So this is the derivative of the function f. Now you have to evaluate at the point 1. So what will be the f dash at 1? Just put t equals to 1. So what it will be 2/7, this 1 to the power it will be 1 to the power minus 5/7, and e to the power 1 to the power 2/7, right? So what this is, then it will be 2/7, this is 1, this will be x e, right? So 2e/7. So the answer is 2e/7. So the second answer is correct. Is this fine? F dash at the point 1, it will be 2e/7. Okay. So question number 3 is done. Question number option 2 is correct. Now move to the question number 4. What it is saying, fx is cos x and g is defined f of x fx. So you have to, what will be the g? Just put here f. If you put x fx, then it will be f of x cos x, right? Now what is f? F of at the point x, it will be cos x. So but here instead of x, it is x cos x. So what will be this? Then it will be cos of x cos x, right? So this is the function g. Now as for the previous question, we have to differentiate it and evaluate at the point pi/2. And for that, note that x, cos x and cos, all these functions are differentiable in R. So everything g is also differentiable. So just simply differentiate it by chain rule. What you will get? What will be the derivative of g? Then g dash x, it will be, first you have to differentiate cos, so it will be minus sine of x cos x. Now you have to derivative the inside part x cos x, so it will be again the UV formula. So first derivative x, it will be cos x plus minus, it will be x sin x, right? So this is the derivative of g. Now what it is saying, then you have to evaluate at the point pi/2. So just put, so what will be the g dash of pi/2? So minus sine, it will be pi/2 into cos pi/2, and this it will be cos pi/2 minus pi/2 into sin pi/2. Okay. Then what is the value of cos pi/2? It's 0, right? And so inside it will be 0, and sine of 0 is 0, and if this function is multiplied with this, so everything will be 0, as cos pi/2 is 0, right? Cos pi/2 is 0, so everything will be 0. So g dash at the point pi/2 will give the value 0. So which answer will be correct? So fourth option. So we get g dash pi/2 is 0. Is this fine? Okay, so let's move to the fifth question. Okay, so what it is saying, fx is given, fx, what it is fx, fx is x sin x in the interval for x belongs to minus pi by 2 to pi by 2. You have to find the values of c such that f dash c is 0. So first you have to find the derivative of f. So what will be the f dash of x? It will be again UV formula. So first it will be cos x, or sorry, so it will be sin x plus x cos x, right? And differentiability of f is obvious, right? Because x and sin both are differentiable function on R. So now you have to find the point C where that this derivative will vanish. So means you have to put f dash of x should be 0. Then you have to let f dash should be 0. Then we will find which point it will give the 0. So means sin x plus x cos x equals to 0. Or what is the meaning of this? Means sin of x is minus x cos x, right? So this is same as tan x equals to minus x, right? So you have to find all the x for which tan x equals to minus x, right? Have you seen this kind of problem? Means fx equals to x. Have you saw what is the called? These are the, so means this is something, some fx equals to x. If suppose this kind of, suppose you have to solve this phi of, let me put here phi. You have to find all such x, find x such that phi of x equals to x, means these are called the fixed point. So means suppose this is 0 and r, this will be the curve of x, and suppose any phi is there, so where it will intersect, this will be the solution. So these are called the fixed point of the function phi. So here you have to not just like fixed point, but it is x, instead of x here it will get minus x, right? So you have to check where this will satisfy. So if you now draw this, how the tan x will look like? At 0 it will be 0, and pi by 2, this goes to infinity, and minus pi by 2 also this goes to infinity, right? Sorry, let me put it here, minus pi by 2. So tan x will look like this, right? This, and again here if you put this kind of tan look like this, again here it will be look like this. So this is the curve for tan x, right? So this is the x axis, this is y axis. Now you have to draw the minus x curve, right? So this is the minus x curve, right? Y equals to minus x. So where tan x and minus x will cut, these are the points where these are the cuts, right? So again tan will be look like this, so it will cut infinitely many times, right? So this has infinitely many solutions. So tan x equals to x. So by the picture you can show, by the picture we can see that yes, you can see that tan x equals to minus x has infinitely many solutions. now you have to, so it has infinitely many solutions, so among you have to find which answer will be correct. So you can see that x equals to 0 is also a solution, not, because 0 they are both intersect, because if we put 0 here, tan 0 will be 0 and it will be 0. So not x equals to 0 is a solution for tan x equals to minus x, right? So at the point 0 it will cut, so c equals to 0 will be the one option. At the point c equals to pi by 4, is this satisfies tan x equals to minus pi by 4? So if x equals to pi by 4, what happen? Tan pi by 4 equals to, it is 1, right? But minus x, it is minus pi by 4, right? So these two are not equals. So tan pi by 4 not equals to minus pi by 4. So pi by 4 is not a solution. So pi by 4 is not a solution for tan x equals to minus x. So the second one is not, so it's false. So similarly you can see minus pi by 4 will not be a solution of the tan x equals to minus x, right? So B, C will be false, and does not exist, it will also not be true. So which option is correct? So C equals to 0, at the point f dash C will be 0, because we have find that C at the point C, this will satisfy, mean the solution means both side will be satisfied. So f dash x will be 0. So f dash 0 will get 0, right? So C equals to 0 is the correct answer. Is this fine? This problem? Problem number 5. And also the point should be lying between minus pi by 2 and pi by 2, right? And you can see from the curve that in between minus pi by 2 and pi by 2, it will not intersect any other point instead of 0, right? So only 0 will be the solution in the interval minus pi by 2 and pi by 2, because we have to only find the solution in the interval minus pi by 2 to pi by 2. So there is only one solution, 0 is the only solution in this interval, right? Here. So 0 is the correct answer. Okay, if this is fine, then move to the next question. Now question number 6. So what it is saying, fx is ln mod sin x. So you have to say that f is differentiable in which interval. You have to find the interval where f will be differentiable. So first f should be defined, right? So just note that you can simply eliminate all the, means some of the options from where the log is not well defined. So the first one, at the, it's only the interval minus pi by 2 to 0. At the point 0 it's not given, so the first one is fine. So then second one, for x, if x belongs to in this region minus pi by 2 to pi by 2, then 0 is here, right? But sin 0 is 0, so log is not well defined. So as sin 0 is 0 and ln is not defined at 0, so minus pi by 2 and pi by 2 is not, here f will be not defined, as it is not defined, so it will not be differentiable there, right? So the second option is wrong. So f is not defined 1 minus pi by 2 to pi by 2. So this option is wrong. Minus pi by 2 and pi to pi by 2 option is wrong. Now what will be the third option? What is saying? F is differentiable on r minus 0. So this one is the for the option 2. Option 3 not, because sine is where sine will be 0. This is ln of sine x, right? But here the domain you have to check in this domain here, right? But sine x has zeros on n pi, right? So in this domain sine has infinitely many zeros, so then again log will be not differentiable, so again not defined. Again ln is not defined at n pi, as sine n pi is 0, right? So here also r minus 0 is not the correct option. And so if this is not whole r minus 0, then f cannot be differentiable in whole r, right? So all last three options are false, right? Because f is not defined in all this interval everywhere. So only the remaining option is this. Here we have to check the differentiability of the function f in the interval minus pi by 2 and 0, right? 4 is similar. So just consider the option 1. So here the domain is minus pi by 2 and 0, right? And function is ln mod sin x. This is mod. So what is the curve of sin x look like? Here it is 0. So at minus pi by 2 0, so this, if this is pi by 2, this is minus pi by 2. Oh sorry, this is pi. And also this is pi minus pi, and this is minus pi by 2. So here the log function is look like this, a sine function, right? So in the interval minus pi by 2 to 0, sine is negative. So as sin x is less than equals, no, strictly less than, because 0 is not included. This is 0 on here, right? Minus pi by 2 to 0. So what will be the mod sin x? So it will be minus of sin x, right? Because sin is itself negative, so if we put minus, it will be, because it will be positive, because modulus is always give the positive. So this in the on this interval in minus pi by 2 to 0, mod sin x is minus sin x, means here it is positive, not negative. Then fx will be, then fx ln of mod sin x, yes, it is ln of minus sin x, right? On minus pi by 2 to 0. And note that on this, on minus pi by 2 to 0, sin x is differentiable, right? Because it is differentiable on whole r. Differentiable. And mod of sin x means it makes it positive, and so domain of log is always positive, because here its mod is given, and ln is also differentiable for ln x. I am writing is, or y, for y greater than 0, right? So fx is simply the composition of these two. So as f is composition of ln and minus sin x, and both are differentiable, and so as composition is differentiable, so f is differentiable on minus pi by 2 0, right? So the first option is correct, means fx equals to ln mod sin x is differentiable on the interval minus pi by 2 to 0, because it is the composition of two continuous function, right? So option A is correct. Is this fine? Yes. Okay. Okay, then let's move to the next question. What it is saying? Question number 7. Fx is given x square minus 2 for all x belongs to R. You have to find the critical point of f. Means critical point means where the function derivative of the function is 0. So to find C where f dash C is 0, right? You have to find the point C belongs to R, real number, where the derivative of the function is 0. So first differentiate it. Note that this is a differentiable function because x square is differentiable, minus 2, x square minus 2 is also differentiable. So what is derivative of f dash x? This is 2x, right? Now, so you have to find at which point it will be 0. So let f dash x is 0 or 2x will be 0, means x should be 0, right? So what will be the value of C? So C will be 0, right? So 0 is the critical point of f. So C equals to 0 is the critical point of f. Means where the function is 0, right? So which option is correct? So option A is correct. All other points not. So all the options are wrong. So is this fine? Question number 7. Okay. This is fine. Let's move to the next one. 8. Question number 8. What it is saying? Fx is x square minus x, and in the domain x belongs to 0, 2. You have to find at which point the function f dash attains the mean value of fx. Mean value means its derivative will give the average or mean, right? So you have to find at the which point it's means mean value theorem. What the mean value theorem says? Yes. Yes. Lakshmi, you are saying something? Yes. Okay. So what is the mean value theorem for this? What is mean for differentiable function? Mean value theorem. This is the mean value theorem, right? What is? If f is differentiable, suppose f is defined in the interval a b to r and differentiable, continuous and differentiable on the open interval you only need. So this is continuous and differentiable on open AB. Then mean value theorem is saying that there exists a C between open AB such that FB minus FA by B minus A will be F dash C, right? So means if you find the slope, then at some point, means for the chord joining between FA and FB, then chord will be parallel to the tangent point at some point, right? So you have to find this C. This is the mean value of the point C. Find X. So you have to find this X. So you have to find this C or F, right? Okay. So you have to find this C. So for that, what you need, you have to differentiate the function and you have to calculate the FB, FA, and then you can find it, right? So Fx is x square minus x. What is the derivative of Fx? It is 2x minus 1, right? And now calculate, because and where this function is defined, so this is defined for all x in 0, 2, right? So now compute f of 0. What will be f of 0? If you put it is 0. F of 2, what is the value at the point f of 2? So it is 4 minus 2 means 2. So now use this one. Now put it here. So what you have to find this C, right? So f of 2 minus f of 0 by 2 minus 0 equals to f dash C, right? You have to find this C. So just simply put it, what it is, f2 is 2 minus f0 is 0 by 2 minus 0 equals to f dash C, what it is, 2C minus 1. Or if you calculate it, what you will get, 2C minus 1 is 1, right? So this means that C is 1, right? So this we need. So this is the mean value of the f. So at the point at which the function f attains, is the mean value of fx is 1, right? We get 1. So the second option is correct. Is this fine? Question number 8. No other options are correct, so only option 2 is correct. Okay, if this is fine, then move to the question number 9. What it is saying, fx is given x square into x square minus 4, then you have to say which points is the local maximum and minimum. So fx is x square into x square minus 4, right? So if you find some point its local maximum minimum, you have to differentiate it and you have to check at which point f dash will be 0, and if it is the local maximum, then f double dash will be less than 0, and if it is minimum, then f double dash will be greater than 0. So let's first find the derivative of f. So f dash x will be, just use the UV formula. So it will be, or simply you can write what it is, you can write, just do 2x into x square minus 4 plus x square into 2x, right? Or means 2x cube minus 8x plus 2x cube, right? Means 4x cube minus 8x. So take the common. Am I correct? Yeah. So 4x will be common. So it will be x square minus 2, right? So this is the derivative of f. Now you have to put where this f dash will be 0. Right? So if f dash x is 0 means 4x into x square minus 2 should be 0. Means either x equals to 0 or x square minus 2 is 0, or this means x equals to plus minus root 2, right? Yeah. So we get 3 points where the f can have local maximum or minimum. So 0 plus minus root 2. Then you have to check whether it's maximum or minimum at that points. So just let's first let's then find the f double dash x, because you have to put the all these points x equals to 0 and plus minus root 2 at the double derivative of f's. So what will be that x double dash? So it will be, because this is f dash x, so you find the f double dash x. So it will be 4 into x square minus 2 and plus 4x into 2x means 4x square minus 8 plus 8x square, or 12x square minus 8. So we get this is the double dash of x. Now you have to check these 3 points. So first check x equals to 0. So put f double dash at 0. What we will get? So 12 into 0 minus 8. So we get minus 8, right? So this is strictly less than 0, mean so x equals to 0 is local maximum. So let's go to the options. Which option is correct? X equals to 0 is local maximum, x equals to 0 is local minimum. It's false. Now we have to check the remaining points. So let's check x equals to root 2. F dash double dash at the point root 2. What it is? So it will be 12 into 2 minus 8. Means it is 24 minus 8. It's 16, right? So it's positive. So x equals to root 2 is local minima. Right. So let's go to the question. X equals to root 2 is given local maxima. It's not, so this is false. Now check the last one. X equals to minus root 2. So because it is x square, so again what it will be? F double dash at the point minus root 2. It will be again 12 into 2 minus 8. So 16 when it's positive. So x equals to minus root 2 is local minimum, right? Local minimum. So go to the option. X equals to minus root 2 is local maximum. This is again false. So we get only option A is correct. X equals to 0 is local maximum for f. Is this fine? Question number 9. So for maximum minimum you have to find the f dash and f double dash. So put the f dash equals to 0, you get the points and put that points on the f double dash. If you get it's positive, it will be local minima. If it is negative, it will be local maxima. Right? Okay. So 9 is fine. Move to the next question. Last question this is. Here you have to say fx. What is fx is x square minus x plus 1 in the interval minus 1 comma 0. You have to check the in the interval minus 1 comma 0 the function is increasing, decreasing, neither increasing or decreasing, or none of the above. So when increasing decreasing means if the function is differentiable, if f dash is greater than 0 means the slope is increasing, right? So function will be increasing. So you have to check, and if f dash is less than 0 means slope is decreasing, means function is decreasing. So you have to check the f dash, what is f dash is positive or negative in this interval. And because here the function is differentiable, so differentiate the function. F dash x is 2x minus 1. So you have to find whether f dash is positive or negative in minus 1 comma 0. So when this will be positive or negative, so 2x minus 1, right? So where it will be negative, so f dash, when it will be positive, just check, mean 2x minus 1 should be greater than 0, right? X should be greater than half, then it will be positive. And where f dash is less than 0 means 2x minus 1 should be less than 0 or x should be less than half. So when x is less than half, f dash is decreasing. So here, so this is the point half. So for all this x which lies here, so here f dash is greater than 0 in this part, and in this part for x less than half, f dash is less than 0, right? And what you have to check here, in the interval minus 1 comma 0. So minus 1 comma 0 means this, right? This is minus 1 and this is 0. So you can see that in minus 1 comma 0 f dash is less than 0. So as, okay, on minus 1 comma 0, on minus 1 comma 0 f dash x is less than 0. So the slope is decreasing, right? So means this kind of function at the point 0, what is the value of the function? It's 1, right? So the function will be look like this for minus 1 comma 0. Here the value is 1. So this is decreasing, right? And the slope is at the point it's less than 0. So as on minus 1 comma 0 f dash is less than 0, so f is decreasing on minus 1 comma 0. So which option is correct? Increasing, it's false. Decreasing, it's fine, correct. Neither increasing nor decreasing, it's second false. None of the again second false. So function is decreasing in the interval minus 1 comma 0. So this is it. Is this fine? Okay. So it's done. This is the last question. Any question from this assignment 3? Hello? Any question from assignment 3? Or is it fine?
Please show all the questions, sir.
Yes.
Please show all the questions, sir. Show all the questions, sir.
Yes. Can you tell me?
Show all the questions on time, sir.
Yes, tell me. Some noise is coming, I can't hear you. Can you write it in the chat?
Yes, sir. I will see again, sir.
Can you write it in the
The
chat?
questions are... Yes, sir. I will take it.
I cannot hear you properly. Yes. Thank you. Thank you, Pilo. Yeah, Sanjal, Arjun, do you have, are you writing or? So let me stop the recording, and if you have any question then you can ask. So let me stop the recording.